The topic which I am presenting is the climate change impacts and resilience options for Indian marine fishery sector. Actually, the work which I am presenting here is the work which is done in the project, that is National Innovations in Climate Resilient Agriculture, which was initiated in 2011. That time it was headed by Dr. Vivekanandan, and later I became the PA of this project. And at one time, there were around 46 scientists working in this project at various centers of CMFRI. So coming to this topic, that is global warming and climate change, these are the two words which we are daily hearing. And I have to tell briefly what is this global warming and what is this climate change. So global warming is the term used to describe the current increase in the Earth's average temperature. And the climate change is actually a fallout of this global warming. Actually, there is we can call it as a side effect, like changes in wind, then rainfall. We expect sometimes we get excess rainfall, sometimes we get drought. Then also we get nowadays we get a lot of extreme climatic events like droughts and floods. So these are all fallout of this global warming. And global warming now, because of these emissions by our human-made emissions of greenhouse gases like carbon dioxide, methane, and other GHGs, our temperature has increased nearly 1 degree Celsius from the pre-industrial area. So this rise will play a very critical role in changing our impacting our environment. And as I said, this most important greenhouse gas is carbon dioxide, then methane and other GHGs. These are all products of our activities like industrialization, agricultural activities, then burning of fossil fuels, then this rearing cows. All those things all will help, or will contribute to the release of greenhouse gases. And coming to this carbon dioxide, during pre-industrial area, it was less than 300 ppm. Now it was in 2018, it has crossed 400 ppm. So the rise in this carbon dioxide concentration is increasing year by year, and it will play an important. It will impact our environment in a drastic way. So if you see this IMD State of Climate 2019 report, says that 2010-19 was the hottest decade in India in the last 119 years. And also the annual mean temperature was found to be 0.36 degree above the normal rate. Then sometimes we get excess rainfall, whereas many places there were droughts. And during this period, 8 cyclones in Indian Ocean with much damage on the east coast was seen. And in the Arabian Sea, against the usual one, 5 cyclonic storms has happened during this period. And extreme events such as snowfalls, thunderstorms, dust storms, cold waves, and heat waves are also were recorded during this period. And not because of this, infrastructure damage has happened, and around 1,500 human lives have been lost because of this changes, climate change. And this coming to the Sustainable Development Goals, which is also known as global goals, which is adopted by the UN member states in 2015 as a universal call to action to end poverty and protect the planet, and also to ensure peace and prosperity by 2030 for all the people. So this is the Sustainable Development Goals, and about 17 goals are there. And what we are interested is goal number 13, that is the climate action, and goal number 14, that is life under water. So this coming to this climate action, there are coming to the facts and figures. I have, as I already mentioned, 1 degree Celsius temperature has happened during pre-industrial levels. Then sea level also has risen by about 20 centimeter since 1880, and are projected to rise another 30 to 120 centimeter by 2100. And to limit warming to 1.5 degrees Celsius, that is what is now the ambitious level of temperature rise which we want, but it is very difficult. 1.5 degrees Celsius to 2 degree, that is that only is possible at this level of global warming. So the global net carbon dioxide emission must drop by 45% between 2010 and 2030, and reach net zero around 2050. That is the that is a plan. And also, climate pledges under the Paris Agreement cover only 1/3 of the emission reduction needed to keep the world below 2 degrees Celsius. And coming to the goal number 14, that is life below water. We know that around 3 billion, that is around 300 crores people depend on marine and coastal biodiversity for their livelihoods. But we are seeing that around 30% of the world's fish stocks are overexploited, reaching below the level at which they can produce sustainable levels. And coming to the marine fisheries, which plays a very crucial role in providing food security and livelihood, particularly in the case of developing countries. And according to FAO reports, fish comprise about 20 to 50% of the annual protein diet in the diet of about 3 billion people. And according to scientist Brander, he has noted that by 1990, the global exploitation in food level has happened, with many fisheries now classed as overexploited. A study published in Science says that climate change is responsible for the distribution shifts in 70 to 75% of the 360 species that were studied. Actually, this is also, we have also noticed this sort of shift in the latitudinal shift in case of our species like whale sardine and mackerel. So this agrees with the exploration made by the scientist. And coming to the projected impact of climate change on marine fisheries, you know the greenhouse gases are the one which causes the global warming, and the impacted parameters are the increase in rainfall intensity, storms, rise in sea level, which results in inundation and physical impacts on coastal areas, which requires rehabilitation of the fishermen to inland areas. Then this GHGs cause rise in SS, sea surface temperature, rise in salinity, decrease in pH, and this results in change in El Nino, La Nina, then change in current water mass movement, then seawater acidification, which results in changes in distribution, abundance, and species mix of organisms, as well as biodiversity loss because of these things. And when the fisheries impact is that vulnerable species may disappear commercially from the catch. We have studied what are the species vulnerable and what are the vulnerability reasons also we have studied. Coming to the Indian marine fisheries status, India is ranked among top 10 fish producing countries in the world. Actually, India ranks around by I think 6th or 7th in the marine fish production status, and also it contributes significantly to socio-economic development of coastal population. And the 2019 production was 3.6 million tons, which generated around 78,000 crores at the landing center itself, and it contributes 1.1% of the GDP and 5% to agriculture GDP. And by this foreign exchange, we earned foreign exchange by exporting fish products around 36,000 in 2019, and it is a source of livelihood for about 4 million people. And it employs directly and indirectly around 1.2 to 4 million people, according to 2016 census by the CMFRI. And almost equal employment is also in allied activities like selling, marketing, processing, repair, etc. You can see that in 2012 was the maximum we have recorded. After 2012, this catch is now showing in a fall. And in 2019, the catch has reached 3.56 million tons, which is mainly contributed by mechanized vessels, 83%, motorized 16%, and non-motorized 1%. Earlier years, it was non-motorized, which contributed substantially, but that percentage has come down significantly. You can see that the catch after 2012 has decreased, and in 2018 there was increase, but it also decreased. And Tamil Nadu emerged as the leading contributor to marine fish production, followed by Gujarat and Kerala. And this is the major fishery resources in India till 2019. You can see that oil sardine, Indian mackerel, ribbon fishes, cephalopods, lesser sardine, pinnate prawns, non-pinnate prawns, threadfin breams, orchids. These contributed substantially to the Indian marine fish production. But in 2019, you can see that the major resource is replaced. Oil sardine has been replaced by Odonus niger. It is actually not a good table fish. It's a bycatch, which it is mainly used for this manure, fish manure, and some larger size is used for table fish also. But this Odonus niger has red-toothed triggerfish. This has all of a sudden, but in 2018 it started, but in 2019 maximum peak landing has come. You can see that resources like non-pinnate prawns, lesser sardines, Indian mackerel, threatened breams, oil sardine shows decline, whereas only this resource, Oris tiger and cephalopods, anchovies, and pinnate prawns show some increase in the landings. And there, there are several issues which marine fisheries is facing, like unregulated open access fisheries. Though we are moving to a regulated situation, but still there are only few, that is, it is not, it's only a snail space only it is happening, except this regulation of boat building yards, number of boat building yards, and also licensing the fishing boats. Except these things, there are even anybody who wants to can take a license and enter into the fishery. Then over capitalization, number of boats are the number of boats are more than what is required. Then in the 50-meter depth, that is inshore area, there is excessive fishing pressure. Then also there is a decrease in fishing area due to industrialization, and also fishermen are moving away from fishing activity. That is one important feature which we have noticed. Then discards and indiscriminate exploitation of juveniles of commercially important fishes. Actually, when this they don't get catch, they sometimes target these juveniles or this sometimes bycatch the target to make it a break even. That is what is happening nowadays when these resources are almost disappeared. They target these juveniles. Then because of the bottom trawling, this habitat degradation happens. Then there is inter and intra-sector conflicts between artisanal and mechanized sectors. And this industrial, domestic or pollution, and also the ecosystem damage is another important problem faced by the marine fisheries. Then though we have Marine Fisheries Regulation Act, it is not effectively implemented. That is one aspect, which is then CCRF, Code of Conduct of Responsible Fishing, is tardy implementation. Then global pressure on trade. Actually, sometimes if there is a demand for a particular species in global level, then that particular species will be targeted. So like that, there are several issues which we face, which is faced by the marine fisheries. But now all these problems are exacerbated by the climate change. So another problem has emerged, that is climate change. So we have made some climatic projections and its implications on marine systems. So we have studied the precipitation, then sea surface temperature, sea level rise, then sea surface salinity, pH, and chlorophyll. And we have made these projections in different RCP scenarios. Now, in place of SRES scenarios, now it is RCP scenarios, representative concentration pathways. And we have, from the model output, we have found that there is unique variation in the Arabian Sea and Bay of Bengal. And one aspect which we have seen is that there is change in fish distribution and phenology. As we know that 1 degree rise in temperature results in 10% increase in the metabolism. And also by increase in metabolism, fishes require more oxygen. So there are changes happening in the distribution ships of oil sardine and mackerel. Earlier, oil sardine was found in the southern latitude, but now we can see a lot of this resource in the northern latitudes, especially in the east as well as west coast. Then we have observed that earlier maturation at smaller size is happening in the case of this Nemipterus, and also in the case of prawns, pinnate prawns. And because of this earlier maturation, less fecundity is happening, less number of eggs per kilogram body weight. This impacts the recruitment success of the fishery. Then change in trophic interaction of species because of this change in the diet. We have found that in the mackerel diet, earlier it was diatoms were more seen, but now we find more dinoflagellates. Then loss of spawning synchronicity. When the spawning period changes with the precipitation or rainfall and all, and productivity also, it should coincide with this thing. When there's change in spawning season, the recruitment also may lead to a failure. And we have seen that there are changes in the zooplankton in relation to pH. We have found that now macro zooplankton is found to dominate the community, but micro zooplankton were found to be negatively impacted. So this low biomass of micro zooplankton can negatively affect fish recruitment. And however, larger crustacean larvae were not affected, indicating size-based vulnerability to ocean acidification. And we have found that the harmful algal blooms, the occurrence of harmful algal blooms have increased in over the years. Earlier, you can see that in 1915 there were only one or two, but now we have seen that around 60, more than 60 algal blooms have occurred in the 2010 period. This is due to the change in temperature, salinity, and irradiance, water stability, nutrient-rich water mass, and prey availability that influence the bloom formation. And also regarding the extreme climatic events, we have seen that in 2000 to 2020, around 31 cyclones have happened, and 10,587 human lives have been lost. And also we have made an estimate of the value. This is only a rough estimate. 2.46 lakh crores has been lost because of this extreme climate events like cyclones. But the silver line in this is that loss of life and property has considerably reduced because of early forecast and warning, and also better disaster management system in place. But still there is scope for improvement. And the IT case, which we have also compiled, and awareness building and effective networking will further reduce the losses. These are the cyclones over the years from 2000. I have listed the cyclones and also the life lost, fishing days lost, etc. So around 31 from up to 2020, this is the list of cyclones happened in east as well as west coast. Some of the photographs of the devastations happened due to the cyclones. And another impact of climate change is to corals. Actually, corals, we know that corals, there is a symbiotic relationship of Susandale with corals. And if the temperature, we have found that there is, because of the heat waves, marine heat waves, if that rise, there's a sudden change in temperature about 1 degree Celsius or 0.5 to 1 degree Celsius rise in sea surface temperature. If it persists for more than 10 days, it will lead to this Susandale will become, it will fall out from the, leave the coral tissue, and these corals will not give it diet food, and it will turn white, and then it will susceptible to disease, and also it will get destroyed. These are some of the photographs of the coral bleaching happened in waters. In 1998, 2010, 2016, five major Indian coral blast bleaching has happened in Andaman Nicobar, Lakshadweep, Gulf of Madan, Gulf of Kutch. The report says that IPCC report says that even if we restrict the temperature rise to 1.5 degrees Celsius above the pre-industrial levels, 70 to 90% of the coral reefs will be lost by the middle of the century. So this is the one unfortunate thing which is predicted by IPCC. Coming to sea level rise, it is projected that a 1 meter sea level rise will displace approximately 7.1 million people in India, and about 5,764 kilometers of land area will be lost, along with 2,200 kilometer coastal roads. It will have a serious impact on the coastal population. And about 30% of the India's coastal zones will be subject to inundation risk with sea level rise and intensified storm surges. And it is said that SST, sea surface temperature of 28 degrees Celsius, is considered an important threshold for the development of the major hurricanes of categories 3, 4, and 5. And this is as per the satellite data, it shows that per rate of change in sea height is 3.3 millimeters per year. So in 10 years, we can expect around 30 millimeters, that is 3 centimeter rise in sea level can happen. And coming to the mitigations, we have estimated how much is the carbon dioxide emission from fishing activities. We have found that per 1 ton of fish, nearly 1 ton of carbon dioxide is emitted. Though it is comparatively very less, it is very less compared to, maybe it is total carbon dioxide emission, it will form only less than 1% of the total carbon emission from activities related to fishing. And the mitigation actions I study is eliminating inefficient free structure. That is, as I said earlier, excessive capacity, overfishing. Then also we have to improve fisheries management, like reducing post-harvest losses, and increasing waste recycling will decrease the sector's carbon dioxide emission. And also the other technical solution to reduce fuel use might include shifting towards static fishing technologies instead of this active, reactive this thing. We can use this wind-based this thing as well as solar-based this thing. This research is still going on this aspect. So this is another way we can mitigate this climate change. So these are I have listed out these mitigation options: reduce fossil fuel consumption by fishing boats. Then mangroves are considered as blue carbon. Then mangrove protection and conservation to reduce sea erosion. Energy efficient mechanism for propelling fishing boats. Reduce fishing grounds, area searching time by finding potential fishing zones. Actually, is giving these PFE If the fishermen increasingly use this PFE forecast, their searching time can be saved by that way we can save fuel. Then use of wind energy by having sailboats with appropriate engine facility, better preservation of fish to prevent spoilage by using ice and insulated box at sea, and better marketing and cold chain facilities to country places. So these are lacking nowadays, but it is now required. That way we can mitigate the climate change. And coming to climate change adaptation, we have to develop knowledge base for climate change and marine fisheries. That is what we are doing now. Then adopt the code of conduct for responsible fisheries. Then increase awareness of the impact of climate change among the fishermen as well as the public. Then strategies for evolving adaptive mechanisms. So we have moved in this direction, and we have initiated several steps for the climate change adaptation, like a demonstration and popularization of low-cost cage farming technology along the Indian coast. So actually, this is that way we can increase our marine fish production. Already, the production from the capture fisheries is in stagnant level, but only now we can increase the production only by doing the mariculture activities. So for that, we have to use low-cost technologies for cage farming, like local products like whatever is available in our area, which in a cheaper rate. Then in Kerala, we have demonstrated that Pokali farming, Pokali farming was facing some crisis because of the less profit they get from the farming activities, and also it's a low labor intensive activity. So we have integrated Pokali farming with fish farming of pearl spots, mullet, silver pompano by putting small cages in the this waterway. So that way their profit can be improved, and the fishermen now are doing it in Kerala. Also, this silver pompano and cobia, actually they are two species which are climate resilient, and this technology for hatchery production has been developed by CMFRI, and also we have developed several technology for several other species also. Then production of feed for pearl spot like pearls plus we have developed. Then so we have taken steps to increase resilience of fishers and coastal fishermen. Then capture-based aquaculture. Actually, that is these small fishes, juvenile fishes, which people get by this small fishing activity, can be put in small cages, and they can be harvested once they attain the harvestable level. Then awareness creation among stakeholders by arranging training and demonstrations. Then we have also compiled this ITKs regarding this knowledge, indigenous technical know-hows of fishermen about climate change. We have compiled and made us a book. Then this seaweed is actually now is a better carbon sequestration medium, and we have now started popularizing seaweed farming. Actually, now Prime Minister also is giving much importance for seaweed farming, as it is a very good raw material for several industrial as well as laboratory products. And recently we have started doing it in the island of Lakshadweep. This last year only we started it. Earlier, Lakshadweep was not included in our activity. So this year we have started seaweed farming in Lakshadweep and integrated multi-trophic aquaculture. When we do seaweed, one species alone, the production can be improved when we do it with other species, along with other species. Actually, we have done it with the cobia and the seaweed, and we have found that the production of cobia as well as seaweed has increased. Then for direct marketing of fishermen their catch, we have developed a multi-vendor e-commerce for better price for fishermen. and by where we can eliminate the fisherman activities. And also we have taken steps to restore degraded wetland ecosystem and use for aquaculture farming. Actually, there are around 5 lakh wetlands in the country, and we have started. We have collaborated with ISRO. That will I will be talking in the later slides. And we have assessed the relative vulnerability of Indian marine fishes to climate change, and for the different zones, the northwest zone, southwest, southeast, and the northeast. And the environmental criteria also has been considered, as well as biological criteria, then feasibility criteria. And we have found out what are the species which are vulnerable to climate change, and what are the reasons what make them vulnerable, and what are the mitigation measures we can take for this to remove their vulnerability. That aspect we have worked out. And we have found that the species shift has happened. Actually, as an example, we have studied the distribution of Nemipterus in Mangalore, and we have found that the distribution has compared in 1993-95 period to the present period, and found that there is abundance. There is a change in abundance. Now the abundance has reduced, and this is the recent one, whereas this is the earlier one, and we have found that abundance has reduced in the threat film distribution. Also, some climate resistant products we have developed from seaweeds and water hyacinth. Actually, water hyacinth is a big menace in the backwaters of Kerala. So we have tried to develop some biochar that is burning in this with high temperature and making it. So this biochar we have tried to use it as a for paddy fish growth, and found that it gives enhanced growth for paddy. And also this biofuel and enzyme also we have tried to extract from this seaweed as well as from water hyacinth. And these are the seaweed cultivation which I already mentioned, then IMTA, then locust cage construction. And Zero Pambano, as I mentioned earlier, it is a good to grow. It withstands a wide range of salinity. So even brackish water farm also we can use it. Even in sea also we can farm it. It shows a wide tolerance to salinity variations. So it yielded good results when we grew in brackish water farms. And this is IMTA, CBA, which I have been mentioning. In Karnataka, many areas have been inundated due to the invasion of salt water in estuarine areas. And we have found that red snapper, there was a good red snapper quantity, a good quantity was caught from this by this small nets. And we have put it in cages, and after nearly 8 months, 8 to 10 months, we found that it grew to harvestable size. So that way, this fisherman income could be increased. So this is IMTA with IMTA and cobia with the seaweed, Capapacus alveraceae. And this is the technical indigenous technical knowledge of Indian fishermen. We have compiled and made a publication, and this is how actually this in the ITKs, when the old fishermen they disappear from the scene, all these ITKs also will be lost. We have decided that with this has to be preserved, so that we have interviewed fishermen and come out with ITK with reference to climate change. And as a first, we have also started a CMFRI Nicaragua Climate Club. This is already registered under Travancore Cochin Charitable and Literary Act. And this is now we are going to start. Actually, our aim is to involve university research institutions, universities, colleges, NGOs, and coastal self-help groups. And so I request anybody who is listening to this talk can approach us, and also they can enroll in our climate club. And this is where we can bridge the traditional and modern knowledge so as to assimilate and disseminate region-specific impacts and adaptation strategies. So that way we can reduce the climate change impact. And this is the National Resilience Framework for Wetlands and Fisheries. Around 5 lakh wetlands are there, like small wetlands. Actually, We are interested only in small wetland, less than 2.5 hectare area. And this is a wetland resilience plan, which we have to do a regional mapping and assessment. And this will be entered in the GSS-based portal, and later aquaculture can be integrated, and then real-time advisories can be made. Actually, this anybody wants some advices on whether this wetland is suitable for farming, they can get information from this website. So this is what we plan, and we have done it in Kerala, we have done it in Karnataka, and we have done it in initiated in Thoothukudi also. So this is the Wetland app and portal. And this is a collaborative work with SAC ISRO, and they have developed this mobile application portal, and later it was transferred to CMFRI. And we can incorporate this field level data as well as the data samples which collected from the area, and unless lab also can be entered in this Wetland app. And this is the first national instance that a Fisheries Institute collaborating with ISRO to implement a climate resilient framework for the fisheries and wetlands. So this is the MOU which we signed with ISRO. And another thing which I mentioned is climate resilient village development. So for the livelihood enhancement, we have developed a multi-vendor e-commerce framework to enhance coastal fishermen income. So in contrast to typical e-commerce activities where a single firm is benefited, in this case, multiple fishermen SHGs can be registered as beneficiaries. So this is the difference between typical e-commerce venture and this marine fish sales, this multi-vendor e-commerce framework. So this website is www.marinefishsales.com, and we were very active till the outbreak of Corona in 2020. And now again we have to activate these activities now. As government of Himachal Pradesh, after seeing this one, they have invited us and we have given training, and now they are implementing it in Himachal Pradesh. And actually, this is one good development. Actually, some fisheries graduates from Mangalore Fisheries College who visited the Siba hatchery at Muthukadu during their field visit. They were fascinated by the Siba hatchery for Asian sea bass under the Startup India initiative, and they have established a hatchery at Kundapur, and this hatchery is doing well. So this is how our activities are transferred to the field. That is, we are this is activity by the Siba. And coming to the roadblocks to climate action, actually there's a conflict between developed and developing nations. It is said that a lot of money is involved. Climate funds are required for especially to develop infrastructure for developing countries. And there is a tussle between developed and developing nations that who will fund this. Now already developing nations are saying that this all this climate change impact has happened because of their activities, industrial activities, and they should pay for that. So there is a tussle going on, and for these activities, especially for development of infrastructure activities to cope climate change, we require a lot of fund, and fund is a major problem. And a clear consensus here to be attained on actions for climate change resilience, which in turn tackles the policy as well as government approach towards solution. So with this end, I come to the end of my presentation. Thank you.